Let's see a real world example of a quadratic function. Let's say that we run a business and our profit as a function of the number of items we produce is given to us by P of n is minus 0.1 n squared plus 200n minus 12. So this function gives you a profit dependent upon the number of items that you sell. Minus 0.1 n squared plus 200 n minus 12. So you can plug in an n value, a number of items that you sell, and then you can figure out how much money you're going to make in profit when you produce that number of items. So a good question to ask would be, when are you going to maximize your profit? So first, if this is the quadratic function here, which it is a quadratic function in the variable n, right? It matches that form a n squared plus b n plus c. And it's going to have negative concavity because of that leading coefficient. The a value is negative, right? It's minus 0.1. So we are actually going to have a maximum profit somewhere. And let's figure out the n value that gives us that maximum profit. So I'm looking for the number of items that returns my vertex. So if I'm looking for the vertex, the position or the point in the domain that gives me the vertex is minus b over 2a, which when we apply it to our function is minus 200 over 2 times minus 0.1. Simplifying this a little bit, we get minus 200 divided by minus 0.2. Our negatives cancel and we get 1,000. So the number of items that we produce that gives us this vertex is 1,000 items. That is what's going to maximize our profit function. Let's actually figure out what the maximum profit is. So what is our profit when we produce 1,000 items? We've already shown that it's going to be a maximum. Now let's just evaluate 1,000 into this equation, profit equation. And if you evaluate 1,000 into your profit equation, you get 99,988.